Hello, Huskies. We are going to talk about operations with functions today. Not operations like surgery, but addition, subtraction, multiplication, that kind of thing. So to begin with, we are talking about a situation where Jamie and Marion earn money every week, and they are going to try and save their money and maybe put it together to buy something great. Maybe they're siblings. Maybe you've done this with a sibling. You're like, I'll save my money, you save your money, and then we're going to buy something. So let's look at the table. It's blank, and you need to fill it in with values from the graph. So we're going to do Jamie's money in red, and we're just going to fill in the very beginning, when there were 0 weeks, then how much money did Jamie have? So we'll look over on the graph, and it looks like we're going by twos, 2, 4, 6, 8. So in the beginning, Jamie had $2. Okay, can you see that? Then after 1 week, looks like Jamie had $7. And after 2 weeks, we're right here, 8, 10, that looks like $12. And then we had at 3 weeks, $17. So maybe you can see a pattern here that Jamie is earning the same amount of money every week. And hopefully you can see that we are going up by fives. So complete the rest of your table for Jamie's money by adding 5 as you go down. And then we'll look at Marion's money. So that's going to be in blue. I don't have a blue right now. Okay, now here we'll go blue. Okay, so Marion's money. In the very beginning, how much money did she have? She had $6. So she had a little bit more than Jamie in the beginning. But then after 1 week, she only had $9. And after 2 weeks, she had the same as Jamie. They each had $12. But then the next week, Marion actually had less. She only had $15. So you can see that there is a pattern also with Marion. She is adding $3 every time. So you can go ahead and complete the rest of the table for Marion just by adding 3 as you go down the columns. Now we're going to add their money together, because remember, they're trying to save up for something fabulous. So 2 plus 6 is 8. I'm just adding. While Jamie had $7, Marion had $9. Okay, then they had $16 together. And Jamie had 12, Marion had 12, then they had 24 that week. 17 plus 15 is 32. Okay, so you can go across and add all of those, but can we see a pattern? Can we see a pattern as you're going down? Hey, hopefully you can see that we are actually adding 8. Adding 8 every time. I wonder if that's a coincidence that with Jamie's money we were adding 5, and with Marion's money we were adding 8, and with the total, adding 3, sorry, my bad, too early. And then with the total we are adding 8. That's not a coincidence that 5 plus 3 is 8. So what I want to do right now is graph the total. How much money are they going to have all together? Let's graph it on the same set of axes. So in the beginning, they would have $8. Then after 1 week, they had $16. After 2 weeks, they had $24. Then 32. And you can see that we are going to go up by 8 every time, which is kind of convenient since that's the numbers that are labeled on this graph. And we can connect the dots, and it'll be this. Imagine that's straight and then it goes through the line. But this is how much money they have together. Okay, so we added those from the table, and then we stuck them on the graph. We could write equations to represent each of these. Let's do equations. Let's start with Jamie. In the beginning, Jamie had $2. Remember, think way back to linear equations that we did in Unit 3, or even like arithmetic sequences. You could think about those. So we could say f of x. I'm going to say j of x. What? Because Jamie's money, j of x. We've got x is time. It's even labeled down there as being x. And then j of x will represent Jamie's money. So j of x is going to equal, in the beginning she had $2, and she was adding 5 every week. Okay? You could also think of it as, x minus 0. The 0 term was 2, but I'm just going to simplify that to be just 5x. Okay, let's write an equation for Marion's money. You guessed it, I'm going to go M of X to represent Marion's money after a certain number of weeks. And in the beginning, she had $6, and she added $3 every week. Remember the thing that changes, the variable, that's the thing that can be different numbers, and that's what we're going to multiply by the thing that happens over and over again. She didn't have $6 over and over again. She just had that in the beginning before she started. And then over and over again we added 3. That's why it's 3x. Okay, just a little review. Now let's write an equation for the total amount of money. Hey, could I do T of X? Is that okay with you? The total amount of money after so many weeks is going to be, in the beginning they had $8 and they were adding $8 every week. So that's my equation. Okay, so far we have done on your classwork all of number 1, A, B, C, D, and E. Now what I'm going to do is skip on to the back. We're going to come back to the stuff on the front eventually, but I want to show you that what we were doing, adding these values on the table, can also be done just on the graph. So, well, we'll get to number 4 in a second. So let's just look on the graph and see that we could also have just added the values on the graph. Now watch this closely. It's not difficult, but it is new. So right here we know we had a value of 2 and we had a value of 6. 2 plus 6 is 8. And then here we had a value of 7 and a value of 9. 7 plus 9 is 16. And remember how they were both 12 right there? 12 plus 12 is 24. And so it's kind of like I'm saying, well, the blue is this much. That was 15 that day. And on top of that, I'm going to add the red, which was 17. And, oh, that took skill. I did that upside down. And 17 plus 15 is 32. Okay, let's do that again. I'm going to erase this to show a little bit more room. So we're going to start with the blue line from here to here. That is 18. Hi. And the red line at the same x coordinate, right, at week 4, then Jamie at week 4 had $22. And so we're going to say we could take the $22 and add the $17 on top of that, or $18, my bad. And so we're going to get all the way up to 40. See that? The red line plus I took this blue line right here and I stacked it on top. And so that would get me to this point up here, this 40. So we are actually adding on the graph. We're adding the y values together on the graph. So we could predict then, if we knew that at week 8 that blue is Marion, at week 8 Marion had $30. And at week 8, Jamie had $42. Then we would be able to graph way up at the top that you can't see at week 8 that they would have $72 combined. Okay, so we would just go up to 72 and put a dot, and that's where our green line would go. Okay, now let's practice on the back. So this one doesn't have a table, and I don't want you to make a table. I want you to add this just right on the graph. So we're going to kind of start by doing the same thing that we just did with Jamie and Marion. I'm going to say, okay, anything happening at week 0? No. Anything happening at week 1? No. Okay, what's happening at week 2? Here we are. At week 2, the red function is 4 high. And the black function is 8 high. And we're going to add those two together. 4 plus 8 is 12. And that's going to put me right here at 12. Still on week 2. We're all on week 2. Okay, and so what you're imagining is that I took that red section right there and I stacked it on top, and that got me up to the 12. Can you see that? Okay then, so let's do it again at week 3. I'm just going to kind of march across from left to right, and I'm going to say, well, what are my values here? Okay, what are my values here? So now I'm on the 3. And when x equals 3, the red graph is at 6. See that? That's 6 units high. You can count them even. 1, 2, 3, 4, 5, 6. My red graph is 6 units high. Well, how high is the black one or the blue one? It's all the way to here. How tall is that? It's 12. So 6 plus 12, if I stacked that red 6 on top, it would get me to 18, but we already knew that 12 plus 6 was 18. So I'm putting these green dots here. They're going to be important because I'm going to connect them as I go. So the green dot is representing the function where I've added those two together. I've added the function values of f plus the function values of g, and I'm getting a new function that represents adding them together. Okay, let's do a few more. I know I'm really cluttering up the graph with a lot of stuff, but it's not that difficult. Watch again. We're at 4 now. We're just marching from left to right across the graph. At 4, the red graph is 8 high. And at 4, the blue graph is 13. And so 13 plus 8 is 21. So then I know my graph, I fell off a little bit, is up here at 21. So it's going up. Okay, then what happens? Well, at 5, we're saying we're at 5 here, my red graph is 8 high again. It didn't move. It's still 8. But the blue one is now at 9. Okay, 8 plus 9 is 17. So when x equals 5, I am at 17 for y. So can you see that I'm kind of like crossing these off? I erased that one. But as I'm marching across, I'm like just reminding myself where I am. Now I'm at 6. And at 6, the red one is still 8. And the blue is only 1, 2, 3, 4, 5 high. So 8 plus 5 is 13. So I'm dropping all the way down to 13. And just keep connecting the dots as you go. And I'm now at 7. At 7, guess what? Red, still the same. It has stayed constant that whole time. It hasn't increased or decreased. It's constant at 8. And then the blue one is up here at 6. 8 plus 6 is 14. So then I'm at 14. Oh, I started to go back up. Okay, so you're going to keep going this way until you get to the end of both functions or one function, because you can only add two functions together here, so I'll show you what that means later. We're at 8 where x is 8, y also still 8 for the red function, and for the black one we're down to 7. That's only 7 high. 8 plus 7 is 15. So 8 plus 7 is 15. And let's do 2 more. We're on 9. When x equals 9, the red one looks like it's dropped. It's 4.5. I'm just going to write that down over here. And the blue one or black one is all the way up to 8. Right? That's 8. If I wanted to, by the way, I could have written that as 9, 8. That's the point. That's the location right there. But I'm only interested in the y value, in how high that is right now. So I'm just going to think of it instead right now is 8 because I'm trying to add these two together. So 4.5 plus 8 is 12.5. And so my new function would be at 12.5 right there. And the last one, oh gosh, this is looking so messy. If you're OCD, you're probably freaking out right now. You don't have to make this much mess when you graph it, but you can. It helps a lot. So we are now at 10, where the red one is only 1 high, and the next one, the blue one, is 9. It's up there at 9. So 1 plus 9 is 10, and we are going to finish off at 10. So your answer for what we just did, we are adding these two functions together. Your answer is the green graph. Do you see that? We added the two functions together. And at the beginning on the story with Jamie and Marion, we added on the table and then graphed it. But I'm trying to get you to see that you don't need a table. You can just graph it by adding the values on the graph. And that's going to be an important skill. Okay, well, what else can we do? Let's go back to the front page. We are now going to subtract. So we're talking about Stephen. Stephen earns money each week and he spends money each week. Maybe he has a job and he earns the same amount of money every week because it looks like it's going up in a nice linear pattern. And maybe he has some kind of subscription, I don't know, Spotify, Netflix, whatever. He spends the same amount of money every week. I know those are monthly. Don't write me letters. Okay, so let's just fill in the table. The money earned is going to be blue this time. And so in week 0, how much money had he earned? Well, he was at the 24 right there. So in week 0, he had $24. And then at week 1, he had 24. We're going up by 2, 4, 6, 8. We're going up by 2s again. So this is 26, 28 right there. So then he had $28. In week 2, he had $32. In week 3, he had, boom, $36. And you can see that the pattern would be we're adding 4 every time. You get me? Yeah. Okay, let's talk about then how much money he spends every week. That's going to be in red. So in the beginning, he spent to $4. That right there is 4 high. And then week 1, he spent $6. In week 2, he spent $8. In week 3, he spent $10. So it looks like he's spending $2 more every week. Well, then how much money does he have left? Of course, if this was you, and you had money that you were earning and then money you were spending, you would subtract to find out how much money you have left. So 24 minus 4 is 20. $28, spend $6, that's $22. 32 minus 8 is 24, and 36 minus 10 is $26. So that's the little table on the front for 2A. But let's show that table on the graph now. In green, I'm going to graph the values of money that he has left over. So in the beginning, he had $20 left over. Then he had 22, then he had 24, then he had 26. So it's just going up not as steeply as the money he's earning. And because he's earning more than he's spending every week, then it's still going up. And you can see that it's parallel to the money that he spends. So he's basically, he's not getting any more extra money than where he started with. You know, it's parallel. None of that really matters, actually. What we want to talk about is the fact that we just subtracted. So let's practice doing that. And what if we didn't have a table? Let's practice subtracting as if we didn't have a table. Kind of like what we were doing with the adding, but we're going to subtract. So week 0, this is worth 4. And the blue value was 24. And so 24 minus 4 is 20. That's what put us in week 0 at the 20. Okay, let's do it and see if I can do it without writing so many messy lines on it this time. In week 1, we had 6. In week 2, we had 26, 28. So 28 minus 6 equals... sorry, just lost my train of thought. 22. I gotcha. We're here. Okay. So then the next week, week 2, right? We're marching. Whoa, what just happened? We're marching from left to right. There's an arrow down there that changes the page. We're marching from left to right. And so on week 2, he had, $32. And he spent $8. So 32 minus 8 equals 24. And so then we could plot the 24. So can you do it without writing all this stuff out over here? What would that look like? Well, on the graph, we could say we started up here all the way up at 36, and we are subtracting off this much. That much is 10. 2, 4, 6, 8, 10. If we subtract 10 off of that, we're going to start here and we're going to go down 10. 1, 2, 4, 6, 8, 10. That puts me right here. And that's in line with our green. Okay, did you see how I did that? Let's do it one more time on the graph without writing out any. If you want to write those out, great. It's helpful. So right here we had 40. We know that we are up at 40. And at week 4, the money he spent was 12. And so we know that the green one is going to be 40 minus 12, which is 28, right there. Okay, so I hope you understand how you can add and subtract on the graph. Let's practice on the back with a weird one. I know yours are not red and black, yours are both black, but you can look at the one on the video and maybe it'll help you because you can see, oh, that one on the bottom is actually red. Okay, so how are we going to do this? We're going to subtract it the same way. Notice that 0 is right there and right here. 0, right there. Okay, so this is our origin. So pay attention to the negatives. So how is that going to matter, the negatives and all that? Well, we are still going to subtract the values, okay? So we have the value right here. This value is 4, right? From 0 up to the 4 is 4. And then on this one, we have a value of 8. Well, 8 minus 4 is 4, so it's actually going to start us right off right there. So march over, that takes care of that one. Now we're going to march over to the -1. When x is -1, my red value was 6, and my blue or black value was 12, and 12 minus 6 is 6. Oh, so I'm on top of it again. That's okay. There's my first segment of what it looks like to subtract these. Okay, that takes care of -1. Now we're at 0. When x is 0, our red value was 8, and our blue or black value was 13. 13 minus 8 is 5, so we are down to 5. 1, 2, 3, 4, 5. See that? Our graph, our subtraction graph is going down. Okay, now remember that it is very, very important to pay attention to the order when you subtract. Come back up here to the top. This is f of x minus g of x. F is the black one. I've been using blue for that. F is the black one. That means that the values on the black function have to come first. I've been doing 8 minus 4, 12 minus 6, 13 minus 8, not just because that makes it a positive number, but because the function f has to come first. Now that's going to make a big difference right now when x equals, not quite right now, sure, we'll do it when x equals 1. And then we'll keep going. All right, so when x equals 1, we're done with the 0. We're over here where x equals 1. The red value is still 8. And the blue value is up here at 9. 9 minus 8 is 1. So we're way down there, green. So we dropped down here to when x equals 1, y equals 1. But now watch what happens. We're done with 1. Yikes. Okay, I'm not going to try to cross that out. We're at 2 now. When x equals 2, the red value is still 8. It's up here. And the black or the blue value is down here at 5. But we have to have the blue one first. This is 5 minus 8, which is -3. So that means that when the x value is 2, I'm way down here at -3. Here's -3. See that? Okay? So, remember, when you subtract, you have to pay attention to which one comes first. Let's keep doing a few more of these. Trying to clean up a little bit. Okay. When x equals 3, well, my red value is still 8. That's okay. But the first one that we have to pay attention to is the blue or the black one, which was 6. So this is actually 6 minus 8, which is -2. So now I'm back up to -2. Okay, next, still 8 for red. The blue one or the black one, when x equals 4, is at 7. So then I have 7 minus 8, which is -1. So I'm up to -1 right here. Okay. Some of you are probably bored to tears. Others of you are still super confused. I know this is kind of weird to think about. If it would help you, you can make a table for each of these. Make yourself a red table. I mean, this is more work, but hey, if you're confused, maybe it'll help. Make yourself a table of the bottom function, x and g of x. Then make yourself a table, a table of the top function, x and f of x. Put the values on there. For example, I'm not going to do the whole thing, but when x was negative 2, g of x was 4. When x was negative 1, g of x was 6. When x was 0, g of x was 8. When x is 1, g of x was 8. So you get the idea. Then I'm going to do the same thing for f of x, for the same values of x. Now when x was negative 2, then my function was up at 8. When x was negative 1, it was at 12. When x was 0, then the function was at 13. And when x was 1, it was back down to 9. And then you can subtract, these points minus these points, kind of the way that we did on the front. Okay, let's look on the back at number 3. It says that in numbers 1 and 2 we added and subtracted 2 functions, and we did using a table and a graph, but now we're going to do it just using the function notation without a table and without a graph. And I think we've kind of done a little bit of peeking ahead at this, so this might not be brand new. So 3a says find h of x plus g of x. Well, think about this like substitution, right? What does h of x equal? It equals all this stuff. What does g of x equal? It equals all of this stuff. If we're going to add them together, we're going to kind of like substitute all this stuff and all this stuff. So this is what it's going to look like. We're going to get negative 2x plus 7 plus 3x minus 8 because I have added h of x plus g of x. Now you can't just leave it that way. You have to do some algebra to simplify things. And so we're going to combine like terms. We've got negative 2x plus 3x is 1x. And then we have 7 plus negative 8 is negative 1. And you don't even really need this one. That 1 times x is just x. And so this whole thing is going to just become x minus 1. In other words, h of x plus g of x equals, a new function that is x minus 1. Just like that. That's all there is to do. You're just going to add the expressions together and simplify. So let's do another one. It says now we're going to do f minus g of x. So first thing you have to know is there are 2 different ways to write this, and people can write it this way or this way, and these mean the same thing. F minus g of x is the same as f of x minus g of x. And so it's not really like distributing, but you can think of it kind of that way. All you need to know is take the function f, which was 4x plus 5, and we're going to subtract from that the function g. And whenever we subtract, I like to keep it in parentheses so that we can distribute. Okay, so technically you're done, but really we got to distribute and simplify this a little bit. So think of this as a negative 1 that's going to be distributed through there. So I'm going to get 4x plus 5 minus 3x plus 8. And now combine like terms. You're going to get 1x again. Okay, so 4x minus 3x is 1x, and 5 plus 8 is 13. And so this whole thing simplifies to be just x plus 13. Okay, so let's look at C. It says f plus g of x. So the same idea, we're going to add f to g and then simplify. So f of x was 4x plus 5, and g of x was 3x minus 8. And when we add those together, we're adding, so I didn't need parentheses. We got 7x. And 5 plus negative 8 again is negative 3. And so that whole thing equals 7x minus 3. See how we can do this just with expressions. Then the last one, D, we're going to start with g of x, which was 3x minus 8. This is like substitution, remember? G of x, all of that equals 3x minus 8. And we're going to subtract h of x, which was negative 2x plus 7. When you subtract, you need parentheses. But we also have this add 5 thing going on at the end. So distribute your negative, and let's simplify that. And 3x plus 2x is 5x, negative 8 and negative 7 is negative 15, plus 5, well, those combine to be negative 10. So this whole thing turns out to just equal 5x minus 10. Okay, let's look at your homework for a little bit because I know that's why you're watching. So in the beginning, you're going to just add in your table. 3 plus 2 is 5, 6 plus 4 is 10. And then down in the table below, you're going to subtract. Be careful when you subtract because you are going to be subtracting 37 minus negative 11. Always use parentheses when you subtract. And that actually is 48 because two negatives make a positive. So let's do that one again. You're going to have, we're just subtracting the y values because this x part is just telling you that when x is negative 1, the y value of m is 30 and the y value of p is negative 8. So 30 minus negative 8 is 38. Okay, and then on number 4, pay attention. It says p of x minus c of x, so make sure you do the top function minus the bottom function. And it might help you to make a table. Okay, look at number 5 on the back. It's actually identical to number 8. I know they don't look identical, but they are, because what we're going to do is add f of x, which equals 2x minus 4, your paper says, plus g of x, which is negative 5x plus 7, and then combine like terms. So you're going to get negative 3x plus 3. Well, down on number 8, it's written the same way. It's g of x plus f of x. It's just written g plus f of x. So we're going to switch that around and go negative 5x plus 7 plus f, which is 2x minus 4. Combine like terms, and voila, you get negative 3x plus 3. So we're just trying to point out that these two are the same. Number 11, what you want to do is first find f of negative 1. That means, do you know x? Yeah, x is negative 1. So you're going to plug that into your function f. Instead of x, you're going to say 2 times negative 1 minus 4. That's f of negative 1. And that'll be negative 2 minus 4, which is negative 6. Then let's find g of negative 1. That is negative 5 times negative 1 plus 7, which is 5 plus 7, which is 12. But we had to add them together. So negative 6 plus 12 is 6. And that's your answer for number 11. And remember, number 12, it's exactly the same as number 11. It's just written differently. So this is another way of saying f of negative 1 plus g of negative 1. And hey, haven't we done that before? Yeah, we have. Last thing I want to look at is number 13. It says find negative 3 times h of negative 3. So you're going to first find h of negative 3. That means you're going to plug in negative 3 for x into h. So that's negative 3 times 4x. But x is negative 3. So 4 times negative 3 is negative 12 times negative 3 is positive 36. Okay, so if that was confusing, see if you can figure out why. First find h of negative 3, then multiply that by that negative 3. And see how that comes out. Good luck on the rest of your homework.